Welcome to week 4 of 16 weeks of SATs with me, Andrew. Now this week we're going to be diving into known facts. So known facts are everything to do with all those little details that you know already, like your multiplication facts, like your division facts, and how those facts creep their way into SATs questions and potentially have the ability to make some SATs questions really easy when sometimes we maybe think we need to go to a written strategy like column addition, grid methods, bus stop methods, and so on, long divisions maybe even when we don't want to. All that's going to do is soak up a lot of time, when if we can spot our known facts and make some jottings at the same time, we can move through these questions really quickly and get the marks, okay? So that's what today is all about, and we're going to get straight into the video. Just want to give a quick shout out to everybody that's getting involved. Please make sure that you like, subscribe to the channel, like the videos, leave comments. It's really important. If you go away from these sessions and think you want to know more and want to get further on with your preparations, I'd recommend my book, Sats Like a Ninja. It covers everything for arithmetic, reasoning, spelling, grammar, reading. Everything to do with SATs is covered in this book. There's links in the description, so please get your hands on a copy of that, and that will really help prepare you for SATs as well. But that's enough of that. Let's get stuck into the video and really master our known facts. Let's get stuck into today's content then. So as we've said, the main thing today is all about using known facts. So known facts are the facts that we know, and they're very simple things. So as we've said, known facts are things like number bonds, so our knowledge of things like 6 add 4, 5 add 3, 10 add 8, those basic facts, but those facts can help us work with numbers much larger. Again, understanding things like 5 times 3, all of our times tables and division facts, they're our known facts, and those facts are going to help us complete things or complete questions with a few little jottings and notes, and we can work through the problems quite quickly. So if we just start to look at some addition problems, addition, it's not going to help us much with addition, but it will help. It will still help. So we'll quickly look at addition. Now, if we look at these problems, we can quite quickly, if you haven't looked at my midweek video, there's a video during the week on partitioning that's really going to help us partition and jot. So just making notes as we go to accumulate the answer to a problem. So again, our known facts here are really simple. We know that 2 add 6, so this number and this number, 2 add 6 is 8. So we're just going to make a note of that. And we know that this is 30, and we know that this is 20. So we know that that is 50. So 50 and 8 is 58. So we can quite quickly use our known facts to answer questions. Again, in this problem, we've got 3 and 7 and 5. So I'm quickly going to add those ones together. So 5 and 7 is 12. I'm just making a note of that over here. So I'll have 12. And then I'll come back to the next, and I know 40 add 30 is 70. So I just make a note of that somewhere. So I just need to add 40. Just move the screen back. Just need to add 70 and 12 together, which is 82. So we can quite quickly use these known facts to help us answer addition questions. Here we just make the problems slightly more difficult, only because we have more digits within the numbers. So we have a 3-digit, 2-digit, and then 2 3-digit numbers. But again, now obviously we could carry these out by doing a column addition, absolutely. But we can also use partition and jot strategies to just use our known facts if we're struggling. And again, we do that by partition and jotting and just attacking the question from place value, going back right into lesson 1, place value. So here I'd do 6 add 6, the green ones, which is 12. I'll make a note of that over here. Then I'd do 20 add 80, which I know is 100. So I'm just going to make a quick note of that over here as well. And then I've got the blue, which is another 100. So quite quickly, that problem becomes very simple. I've got 212. And that would have been the answer, 212. We'll just write that in, 212, and that would have been correct. Now, again, that just stems from just quickly using facts that we know. Again, if we go on to the second question, we know that these are our ones, we know that these are our tens, and we know that this is 100 and this is 100. So we can attack them quite quickly by just making some notes. So 9 add 5 is 14. I'm again going to miss that out. So I've got 14. 20 add 40 is 60. And then I've got 400s, haven't I? Okay, so quite quickly we can just see how we've got 460, little other note, and then I'm adding 14 to that. So that means I've got 474. So again, quite quickly, by just using what we know and aligning our ones, our tens, and our hundreds, we can quite quickly jot an answer down and work through a problem using the facts that we know. And again, this really does apply to everything that we know to do with maths. So again, just aligning the fact that we have a tenths and we have ones, and both obviously numbers are decimals, 7.2 add 1.9. So very simply, again, we won't get into the deep dive of decimals, but essentially 0.2, so 0.2 add 0.9 is 1.1. So I know I've got 1.1, and then I've got 7 add 1, which is 8. So essentially I've got 8 add 1.1, which is just 9.1. Very simply, we can mentally work through that problem. I'm making jottings, but we're just adding these two together and adding these two together. So 2 add 9 is 1.1, as we've said, and then 7 add 1 is 8. Again, with here, in the next question, again, we're aligning the fact that we have hundredths, and we've got tenths, and in this instance, we've got our ones, but there's nothing in either of the ones. They're just placeholder zeros. So again, very simply, we could have done this as a column addition and lined everything up. But again, our 3,000th, our 300th add 400th. We know if we know our decimals well enough, we know that that's going to be 0.07. And then the 6 and the 2 is going to be 8. So that's going to be 0.8. So those added together is going to be 0.87. So again, you could argue that this, making these jottings and doing it this way, is complicating it a little bit more, because here I would probably just drop into doing a column addition and just lining up my decimals in the same street, making sure they're in their own house, living in the middle of their house, and I would just add it as a column addition. All right, but knowing that we can use these facts and just make little jottings as we go, and then we write our answer. Now, for me, using your known facts really comes into play when we start thinking about multiplication. So these questions are the key ones. It's all about using the facts that we know. So this is where we start. So really simply here, we've got a problem like 6 times 30. Now, I know a lot of you will just know the answer to this, and that's great. So this is probably aimed at people who are thinking, well, I'm not quite sure how I would tackle this. And the key is to just spot the facts that you know, okay? And 40 and 30 here are just 10 times bigger versions of 3 and 4. 3 times 10 is 30. 4 times 10 is 40. So they're just 10 times bigger. So if we look at the question and we just think, right, well, the facts that I know, oops, I'll get a highlighter, are 6 times 3, and I know 7 times 4, then we're basically halfway to answering the question, more than halfway, because essentially 6 times 3 we know is 18, so we could write 18 down, and then obviously we're timesing that answer by 10, making it 10 times bigger, so we obviously times it by 10, so we have 180. So we know that if we have 6 times 3 is 18, 6 times 30 has to be 180. It's just 10 times bigger. It's the same with the second question, 7 times 4. We know that 7 times 4 is 28, all right? So 7 times 40 is 10 times bigger, so that must be 280. So very, very simply, we can take this known fact of 7 times 4 is 28 and spot that here we're just 10 times bigger, so this must be 10 times bigger. So again, 7 times 40, very, very straightforward. And again, we can use these known facts because what most people would do would maybe try and drop into sort of a grid situation where they're trying to do grid method, and it makes things a little bit complicated. Whereas if we just use our known facts, these questions are very simple, and you get these questions all the time in your SATs. So you really, the addition, yeah, absolutely learn that. This bit, this multiplying known fact is essential because you'll waste your time doing a grid method when you can just spot 6 times 3 is 18. So 6 times 30 must be 180. Write your answer in, move on. And again, we have a similar situation here. And this is a classic SATs question, 3 times 400 or 6 times 700. And really what it's doing, what the question is doing is basically saying, can you see this? That's what it's suggesting, is that it's taking you back to your base knowledge of something that you learn in year 3 or year 4, early key stage 2, and can you spot the fact that this is basically saying 3 times 4, and this is basically saying 6 times 7. Forget about the timesing by 100 for now, okay? And we can use 3 times 4 is 12. I'm not going to have enough room to spread it out properly. So if we're timesing by 100, if we here 3 times 4, we haven't times by 100. We've just done 3 times 4 is 12, but now we're doing 3 times 400, so we're multiplying by 100. So the answer must be multiplied by 100, and your little clue, as you know already, is that those zeros are going to end up in the answer. All right, so 3 times 400 is 1,200. Very, very simple. Again, this second question is just going 6 times 700. Really what we need to see is, I know that 6 times 7 is 42, so we would write 42 and know that that's multiplied by 100. So the answer also needs to be 100 times bigger. So the answer is 4,200. And these answers are very, very simple. And again, the danger is that you go into this instead, which is 700 times 6. And then obviously that would have been written much neater with a ruler, so I apologize. So let's quickly do that with the ruler. That would have been much nicer. And then we get, because we're multiplying by hundreds, we have to think about placeholding zeros below, and this all of a sudden becomes really complicated. And I can see children making mistakes when actually this is really asking is, this is a mental calculation. You should be able to spot the multiplication facts. And again, we can take this a little bit further within these ones. Now, in the previous questions, we were multiplying by a 40 or a 70. In these questions, we have 2 digits to multiply by. So again, we're going to start to just make some notes here around partition and jotting. So again, 3 times 4, 3 times 42. Again, it goes back to understanding that we have 2 here and we have 40 here. So all I'm going to do is I'm going to times this number and this number by this number. Okay, so 3 times 40 is 120, but again, spotting that 3 times 4 is 12. And then secondly to that, I'm going to do 3 times 2, which is 6. So my answer is just 126. And again, we're just making very, very simple joins. Again, understanding that this is verse 3 and this is 70, and that I'm going to multiply both of them by 5. So 5 times 3 and 5 times 70. 5 times 70 is where we might come unstuck. But again, it's understanding and spotting that we can get pretty much to the answer by using our known facts. 5 times 7 is 35. So 5 times 70 must be 350. Then we've got 5 times 3, very simple, is 15. And we can just add them together. So that becomes 365. So again, what looks like potentially a really tricky problem, 5 times 73. Oh no, how do I solve that problem? Actually, with just a little bit of jottings and using your known facts, again, I'll highlight those known facts in here. Using your known facts within the question will really, really help you be successful. I'll change the color there because we want to see that as green. To really help us being successful. And again, these questions come up all the time in your SATs. They're easy marks. Don't get bogged down with grid methods when it's very straightforward to just make a few simple calculations. Now, there were lots of examples of these for me to show you. So again, this is a classic one, as you can see here, 9 times 41. Now, again, I could quite imagine children thinking, oh, how do I do this? Or dropping into a column multiplication. Now, again, what I would be doing, or a grid method, sorry, what I would be doing is just making some notes. Again, 41 is made up of 40. Let's change that. Is made up of 40. Change the color again. Of 40 and 1. And I need to times both of those by 9. So 9 times 1 is 9. 9 times 4, I know, is 36. So 9 times 40 must be 360. All of a sudden, we've got our answer, which is 369. Okay? So this is where I mean by just look how simple that was. Just by making a few jottings. And I know they're not in the boxes and stuff, but when we're making jottings, that doesn't particularly matter. The squared paper is really for when we're doing a column addition or an actual written strategy. Here, I'm just making notes, and these notes help me just go, right, well, help me spot my known facts of 9 times 4 is 36. So 9 times 40 must be 360. Very easy way to solve this problem, get the mark, and move on. And again, here's the next one. So again, this question 15, varied representation. So we have the sum here and the two numbers within the question here, okay, and the equal sign. So again, we could go into 596 times 7 in a grid method. But again, what I would be doing, or what I'd be wanting my pupils to show me, is that, well, I know that that's 500. I know that this, if we bring it round, is 90, and we know that this is just worth 6. And again, I wouldn't expect that you draw all these lines. This is just me showing you that I would quickly just make some notes about the 500, the 90, and the 6. And again, I'm just then timesing them by 7, timesing them by 7, timesing them by 7. And I'm going to rub it out because I want to present them the other way around to you. Because if we multiply them by 7, we can then see the fact right next to it. So I know I'm going to times them all by 7. 7 times 500. I'm going to do 7 times 90. And I'm going to do 7 times 6. The reason why I wanted to do that is so that we can see our known facts. We can see the known fact part of the question, which is really going to help us develop our answer. So I know that 5 times 7 is 35. So I know that 7 times 500, we need to multiply this answer by 100. So we have 3,500. 7 times 9 is 63. Timesing that by 10. It's 10 times bigger because 90 is 10 times bigger than that. So that's 630. And then I've got 6 times 7, or 7 times 6, which equals 42. At that point, I've got all of these together, and I can see pretty much where I'm going to go. I can spot that here. That takes me straight through to 4,130. And then I'm just adding 42 to that. So that's 4,172. So again, just mental calculations taking us through, and that answer must be then transferred into the answer box, and that would get us the mark. But I think that's quite a quick way. Obviously, I'm taking you through it in a lot of detail. You could make these jottings quite quickly, and then if you wanted to at this stage, what I would suggest is if you got to this point and you were like, right, okay, I can't do that mentally, you would just quickly pop that into a column addition. 3500 630 42. Okay, I'm not going to get the ruler out because I'm conscious of time. We would add that, and then I just start adding. That's 2, that's 7. 5 add 6 is 11, so we carry the 1, and then there's 4. And then that would have got transferred into the answer box. So we can quite quickly go from jottings into a formal method to help us get the answer. Now, again, if this is me, I'm just jotting straight into this and going, right, well, this is basically 4 times 700, and this is 4 times 2, because there's nothing in the tens column. So we know that this is 8. I know that 4 times 7 is 28. So that must be 100 times bigger. So my answer is 2,808. Dead simple. Answer must go into the answer box of these two numbers being added together, and then we put the answer into here. That gets us the mark. Again, with this question, I just want to be dropping into straight away, spotting the fact that with multiplication, I just need to work out what these are. So the 6 is representative of 60, and the 5 is obviously just 5, and I need to multiply those both by 8. So I'm just making some quick jottings. And again, within there, I can see straight away that I've got my known facts of 8 times 6, and obviously 8 times 5 is dead straightforward. So we can answer this no problem. 8 times 6 is 48, times that by 10, and 8 times 5 is 40. So very, very simply, we can spot them together and know that that's going to be 520. If you needed, at this point, if you still weren't sure mentally, you could quickly drop into a column addition, and you would just add them together very quickly. Again, that's going to be 0. That's carry the 1, 520. That would have got you the mark. So a very simple way of combining partitioning and jotting and potentially some formal strategies in terms of column addition to help you. Again, these questions are, you're not going to get too many of these, you will, but ultimately with any of these, you're probably just going to drop into a column addition. That would make the most sense. But I think it's good practice to be able to do it mentally. These ones, these multiplication facts are very, very important. You need to master being able to do these. Guaranteed there'll be 1, 2, maybe even 3 of these on your SATs paper, and they're easy marks. And it's all about just going, well, I don't need to do 5 times. I don't need to do 6 times 43. I can just do 6 times 40 and 6 times 3 and know that 6 times 4 is 24. And it's easy. It's easy when we break it down into our known facts. So have a go at these questions, particularly these ones. And then after this, I'm going to move into the division side of this, where these division questions come up all the time. I've seen a couple of SATs papers where there's 3 or 4 examples in one paper of the division questions. So have a go, and then we'll move on to division. So as I said, these division questions come up a lot. They come up a lot in the SATs papers. And again, the key is, if we're looking at them, is just to spot the fact that we have got known facts. All right. So the 0 in here, we're probably not really going to focus on that too much. But what we're spotting is the number that we're dividing by. If I highlight this, so in this instance, it's the 2 and the 3. And then the other number of 24, and being able to spot the fact that this number and this number are related multiplication facts. Okay, so 24 is in the 3 times table. 16 is in the 2 times table. So if we just focus on those facts, we can get these answers really, really quickly. So 16 divided by 2 is 8. Change that up again, keep making that mistake today, is 8. But the number that we were dividing initially was 10 times bigger. So the answer would be 10 times bigger. Okay, so 160 divided by 2 is 80. Makes complete sense. Again, if we go on to the next problem, 240 divided by 3, well, let's not get bogged down with 240. Let's just see 24 divided by 3. Makes sense. 24 divided by 3 is 8. Now, the question was 100 times bigger than that. 10 times bigger than that. So 240. So the answer must be 10 times bigger as well. So the answer would be 80. And again, we can quite easily spot these and get easy marks. Let's have a look at some other examples. Now, again, with these much larger numbers of 2,100 and 4,500, the key is looking at the 3 and the 5 and spotting 21 and 45, our known facts within the question. So again, if I just highlight those off with the green, we've got 3 and spotting the fact that 21 is in the 3 times table and 45 is obviously in the 5 times table. So that relationship's really important, and we can use these, as I've said, to get the first part of our answer, or at least get us on the right line using our known facts. So again, with 3, 21 divided by 3 is obviously 7. I'm just going to write it below because I haven't got enough space, is 7. And then the answer is 100 times, sorry, this number is 100 times bigger, so the answer would need to be 100 times bigger. So 2,100 divided by 3 is 700. And again, how many 5s do we have in 45? Well, we have 9. Okay, but again, we weren't dividing into 45. We were dividing into a number that was 100 times bigger. So the answer would be 100 times bigger. So again, that would be our answer, the blue box. We would transfer these in. And again, these are dead easy. It's just spotting our known facts in the question. So again, I've got lots of SATs examples here. And again, the key, we can see 3. So 180 divided by 3. What I'm spotting, if I write this a little bit bigger, if we've got 180 divided by 3 equals, what I'm spotting straight away is that 18 is in the 3 times table. So how many 3s are in 18? Well, there are 6. Okay. But actually the number in the question was 10 times bigger, so the answer must be 10 times bigger. So 180 divided by 3 must be 60. We would write that in and we would move on. Again, another example, I'm just going to write it a bit bigger so you guys can see it more clearly. We've got 2,400 divided by 2. Essentially, that's asking us to half. So if we can just half, then we would know that the answer is 1,200. But again, if we just drop that in here and make it, use the known facts to make it easier for us. So again, if we can't half 2,400 in our heads, maybe we can half 24 and know that half of 24 is 12, but the question was actually 100 times bigger. So the answer is going to be 100 times bigger. So again, the answer would be 1,200, but that was a really straightforward way of just, rather than getting bogged down with such a large number, if we can spot a known fact in there, 24 divided by 2, 24 is in the 2 times table, then we can really answer these questions very simply. Here's another one. And as soon as you see this question, we should be hopefully spotting 3 and 27 and seeing that correlation, that if we have 270 divided by 3, again, this is a SATs question, that 27 is in, and the number 9 should just be jumping out of our brains onto the paper. 3 into 27 is 9, so 3 into 270 must be 90. We would just write 90 in there and move on. And again, you can see how children could spend a lot of time going into a bus stop method and making mistakes along the way, when really all the question wants us to do is show that we can spot these known facts in the questions and do these calculations mentally. And again, we've got some varied representation. Don't be thrown. Again, here we go. Here is the question. So again, spotting the fact that if we had 240 divided by 8, if we know our 8 times table, we should be spotting, and we've got to be alert to this, a little bit like a ninja. I always say that, is that we've got to be alert. When you're doing the SATs paper, you've got to look for these. I'm not going to tell you them. You've got to spot these little patterns and connections. So how many 8s are in 24? Well, there's obviously 3. So how many 8s will there be in 240? Well, there'll be 30, because the number is 10 times bigger. And the key bit is that that must go into the answer box, and that would get you the mark. We've got another 2 questions. That's how common these are, these division questions. And they're there all the time. So again, 560 divided by 7. Obviously, we look at that problem. So we see, again, highlighter, 56 is a multiplication fact within the 7 times table. So that's going to help us solve this problem. How many 7s are in 56? Well, there's 8. The question is 10 times bigger. So the answer will be, so again, that should be a mental, again, question 11. We're moving through the paper. We should hopefully be answering this very swiftly, answer in the box, move on to the next one. And again, a final one here. Now, I can easily see this throwing lots and lots of children, all right? But there's nothing to worry about. Again, if I just write the question out, just so you can see it a bit larger, of 5,400 divided by 9. And again, these questions where the key bit is just spotting the number that we're dividing by and thinking, right, is anything to do with this number in its times table? Yes, 54 is in the 9 times table. It's 9 times 6 is 54. So 54 divided by 9 is 6. Keep getting that grey highlighter, is 6. But the actual number is 100 times bigger. So the answer would naturally be 100 times bigger. So we've got 600. We would get the mark and move on. Now, if you can master these, you will get 3 or 4 marks in your SATs papers every week because these questions are so common. So please look out for these known facts. And finally, we've got some known facts questions for you. And you can practice these yourselves. But again, there's 1, 2, 3, 4, 5, 6. There's 12 in total. Start with these ones and then move on to these ones. But again, the key part is spotting the multiplication and division facts that are within the questions already. All right. Once you've done that, that will make life so much easier, and you're going to guarantee yourself lots of marks in the SATs papers because you know and use your known facts. So well done for getting stuck into this lesson, and we'll jump back to me in my office and we'll round up this week's lessons. Well, who knew? Known facts. Known facts, as I've said all through this video, are so important, especially the multiplication and division questions. And you must get used to spotting those in your SATs questions. Now, between the multiplication and the division fact, you're probably going to get 2, 3, 4, maybe even 5 of those questions in a SATs paper, and they're really easy marks. What we've got to do though is not get sort of discombobulated by them all when we see 5,400 divided by 9, and just knowing that 54 is in the 9 times table. So you know the answer to those questions. And again, these videos are just about me giving you those tips to be able to answer those questions really easily. Now again, if you want to get ahead of things, as I've said, get your hands on a copy of SATs Like a Ninja. That's going to help you prepare in advance for SATs, for reading, for SPAG, for spelling, for reasoning, and obviously for arithmetic. So get your hands on a copy of that. It's really going to help. But other than that, that's known facts done for this week. That's week 4's lesson done. Please make sure you like the videos and please make sure you subscribe. It really helps push things out to a wider audience, which is exactly what we want. And keep practicing throughout the week. That's this week's videos done. Please make sure you get stuck into the practice questions again if you need to. But I really look forward to seeing you all next week. Thanks for getting involved, and thanks for working hard towards your SATs this year.